This is example 5 from the data representation section of the Barron's ACT Math and Science workbook. Let's first look at question number 1 from that example. So I'm going to scroll down to the question itself and see if we can get the answer from the figure. At the bottom we see that question number 1 says, based on the information in the figure, the incandescent object A will not glow at all when heated to 4800 degrees Kelvin. So to determine whether that answer is correct or not, you need to understand what's going on in the figure. So let's look at the figure. We see 3 curves. It looks like an object has been heated to 3 different temperatures, and the curves represent the intensity and the wavelength of the radiation that is emitted from the object when it gets heated. Looks like there's 3 bands of possible light. One is ultraviolet, and in the center we have visible, and to the right we have infrared. And on the y-axis we have the intensity, and on the x-axis we have the wavelength of the light that's emitted. So now at 4800 degrees Kelvin, here's the curve. Is it glowing? Well, the peak of that energy is right in here, so we know it's in the visible spectrum because it's in the middle part of this graph. And if we drop the line down to the x-axis, we see that the wavelength of that light at the peak energy is somewhere around 550 nanometers. And below that figure, we see the colors in the visible part of the spectrum, and we see the wavelength that relates to those colors. So at right around 500, there we go, 500 nanometers, it seems to be blue or green, mostly green. So the fact is it does glow when heated to 4800 degrees Kelvin. So A is not the right answer. So let's look at B. It says the incandescent object will emit ultraviolet radiation when heated to 6800 degrees Kelvin, but will not have a visible glow. So where is the 6800 degrees Kelvin curve? Right here. It's the hottest, actually. So I've made it red. Looking at that curve, we see that the peak energy is right about here. And yes, there may be some ultraviolet radiation, but the peak is actually in the visible spectrum. So B is not correct because the object will in fact have a visible glow. C says that the object will emit an orange glow when heated to 5800 degrees Kelvin. So here's the 5800 degrees Kelvin curve, and we see that the peak energy there is right about at the top of the curve. And if we were to draw down to the x-axis, we'd see that we were about 500 nanometers. And at 500 nanometers, the color is, again, in the blue and green range, not orange. So C is not the right answer. And finally, we go to D. It says that the object will emit a blue glow when heated to 6800 degrees Kelvin. So the red mark shows you that the 6800 degrees Kelvin curve has peak energy at around 450 nanometers. If we were to draw the peak line down to the x-axis, we would see that it would be down in this range right here, around 450 nanometers. And so that color is right in here, and it's in the blue or violet range, kind of right in between, but it definitely will emit a blue glow at 6800. So that's the right answer. D it is. From Summit Online Prep, reminding you to reach for 36.